Welcome back to the next portion on graphs and transformation. So we have officially completed the first part, which is your graph sketching. Now in the second part, we are actually going to be discussing this thing called conics, which has 4 different shapes. So you can think of conics as just fixed shapes slash fixed figures that we need to learn and the equations associated with them. So typically under this section, you will be asked the 2 main questions. You'll be asked to sketch, that's one, and then the other one you'll be asked to solve. And solve for what specifically? It'll be for the intersections, right? Solve for the intersections. So it's typically these two. So the first type of conic section that we're going to be talking about is a parabola. But just to give you a heads up that we're going to be discussing in that, we have this thing called a parabola. We also have this thing called a hyperbola. We also have this thing called a circle, and then the last one will be a ellipse, right? So 4 different shapes, but we're going to be discussing them one by one. So what is a parabola? How I like to remember it is it's just a U shape, and a parabola is something that you have dealt with many times already in the form of your quadratic, right? For example, your quadratic, your equation of y equals to x squared itself is a parabola, right? Because it goes down and then there's a local minimum point and then it goes up, right? Or alternatively, it can go up, have a local maximum point and then go down, right? These two are examples of a parabola. Now, these 2 different parabolas over here, they open either upwards or downwards, right? So for these 2 kinds of parabolas, they have the same general form or the same general formula. So the general formula for these 2 parabolas at hand would be your equation of y minus k equals to, then here you can put a bracket x minus h squared. So the squared over here applies to the x over here, and you know when you expand this, you get x squared plus something, right? This x squared over here suggests that the parabola actually opens upwards or downwards, right? Because if I draw the line of symmetry over here, you can see that the x repeats itself. On the left and on the right, the x actually repeats itself. That's why we have an x squared, because each x value is getting squared, and therefore we have the positive and the negative version of the x in the same graph, right? So this is one kind of a parabola. Another kind of parabola, which is not commonly discussed so far, up until this point, because secondary school never really discussed about this, is another kind of parabola which opens sideways like that, whereby here is the local turning point, right? The local turning point, if you may. So over here, this is the line of symmetry, and then over here, this is the line of symmetry, right? Just gonna draw this straight, and just gonna draw this straight, right? So these points over here is what we call the vertex, right? And then this is our line of symmetry. So you can see that for this type of graph, right, it opens sideways, right? And the y values are the ones that's being sort of duplicated. So if I draw the y-axis, x-axis over here, right, let's say y and x, let's say for each x value over here, there are 2 different y values, right? Let's say I point at this x value over here, there are 2 different y values, right? So each y value is being squared, and that's how we actually get 2 different y values. So for these cases, the general formula would be the opposite. The general formula for this would be x minus k equals to a y minus h squared. So the only difference between these two is where the squared is actually being associated to, right? And actually for this chapter regarding parabolas, there is a lot of ways that you can sketch a parabola, for example using your GC, your graphic calculator, and basically you'll be just using a graphic calculator most of the time. So the main aim of this video over here is to just introduce to you what a parabola is, which is just showing you the general shape and showing you what the general formula of a parabola is, as well as the kinds of parabolas that you can expect to encounter, which is the one that open upwards, downwards, or left or right, right? And as long as you are able to absorb that, then ready to move on to the next portion where we're actually going to practice sketching a parabola. So using the idea of what I taught you over here, try to sketch this parabola. But again, sorry, before we go there, I want to first discuss what's the difference between this one and this one. Okay, whether it opens upwards or downwards all depends on the a value. Okay, the a value here. So if the a value is positive, then the coefficient of the x squared over here will be positive, right? And then we learned in secondary school that if the coefficient of x squared is positive, it's a smiley face, right? So if it's positive, then you'll open upwards. But then if it's negative, then it will open downwards, right? Same thing here. For this equation over here, right? If the a value itself is actually, I should probably not write it this way. Let me just follow the same way I wrote it earlier. Okay, y minus k square equals to a bracket x minus h. Yeah, okay, I'll just write it this way. So writing it this way ensures that the two different formulas are the same, okay? And the only difference between these two is where the square is being placed. So the square is being placed here, or is the square being placed here, right? Actually, you can write it the other way around. Like it all just depends on how you best see it. But writing it this way will be slightly easier because this a value now is associated with the x. Instead of it visually being associated with the y, it's now visually being associated with the x. And you can imagine it as if the a value is associated with the x, and if the a value is positive, then the graph will be pointing this way. And then if the a value is negative, the graph will be pointing this way. Simply because if the a value is, let's say, negative, then I have negative x dot 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 dot, right? And then you're basically saying that the x value will be negative. So if I draw out y and x over here, you can see that the x value should be negative, right? Pointing the other side. And that is basically the whole difference between these two over here. Okay, so hope that made it clear. And now we're going to tackle this question over here where we're going to sketch a parabola. So make sure that when you're sketching a parabola, to always remember the 4 criteria earlier that we mentioned in the previous section, what is required in a sketch of a graph. Pause this video, try it out for yourself, and when you're ready, come back to this video and let's run through the answer together. Alright, so to sketch this graph, we can actually use our GC to sketch this graph, and it's actually fairly straightforward to sketch this graph on the GC. Now, your GC, you might, if you click on the apps section over here, you might just see finance or you might see Conics. So if you have Conics installed on your GC, means that it's been recently updated before you actually purchased it to have this new application. And if there's a Conics option over here, means that you can directly just sketch the parabola without having to do any sort of manipulation, right? That means you will be able to just directly key 2 and -4 into the GC over there, right? But in the event that you do not have one, how do you actually sketch this? It's still possible, and I'm going to be showing you just using this question as an example over here, how it's being done. Okay, so if let's say you don't have Conics with you, what you can do is you just manipulate this to make y the subject. So you have y plus 2 square equals to -4x, and then you have y plus 2 is plus minus root -4x over here, and then you will have y equals to 2 plus minus root -4x over here. Okay, from here. And then you will have y equals to -2 plus minus root -4x, which becomes y equals to -2 plus root -4x, and y equals to -2 minus root -4x. I know it doesn't make sense to have a negative root negative. Yeah, it certainly does not make sense. But you can actually sketch this in your GC. And I'm going to show you how. So if we go back to your GC here, assuming you don't have the Conics app installed, you can just come here, right? And then you just need to key negative. So scroll down here, not able to show you, but okay, let me see if I'm able to show you. Yes, perfect. -2, right? -2 plus square root -4x. Right below, -2 minus root -4x. Graph it, that's your graph, right? You can see there is a parabola that opens to the left, and most importantly, there's a vertex over here. So when we sketch the graph, it's very important to figure out what the coordinates of the vertex is, right? And we can just calculate the value of x as 0 over here, and you can see that it's 2, -2, right? So we can just translate this into our drawing over here. So just gotta draw this down, draw this across, and then you have y, x, right? It comes down here, and then it goes back here, and here would be 0, -2 as the final answer over here, right? Just note that this over here is the line of symmetry. You're not required to draw it, I'm just showing you. And then here is what we call the vertex. Okay, so just some food for thought, right? In case you're wondering. This graph only exists in this portion. Simply because if the graph actually existed in this portion over here, right? Let's say over here for a positive x value, there's a y value, right? If let's say x is positive, I sub inside here, -4 times a positive number will end up to be still negative something, right? And we fundamentally cannot square root a negative number. That's why the x value to begin with has to be negative, right? Because then when the x value is negative, let's say here is -5, then when we sub -5 into here, -4 times -5 gives us +20, and this is a number that is square rootable, right? So that's the whole rationale behind why this is the case. Okay, if not, that's it for this portion over here regarding parabolas. Should be quite easy to master. Let me know if you have any other questions. If not, I'll see you in the next video.